Hey, e-learners for biology. I wanted to go over that story of water with you guys in person. So I asked you guys to draw a diagram of the water molecule, and the water molecule has a bent shape just like this. And one of the things that we were talking about in class that maybe you could or could not hear was that water has a bent shape because it's a polar molecule. And what happens is oxygen is so darn strong that it's pulling really, really hard on the electrons that are shared with the hydrogen. And so you'll see these little like kind of curly Q shapes. That's just a Greek symbol for partial. So the oxygen gets a negative partial charge because it's pulling on the electrons from the hydrogen so hard, and the hydrogens get a partial positive charge. And so that makes there actually be different ends of the molecule. Kind of like the North Pole and South Pole, we have the negative pole and we have the actual positive pole. And so this is a polar molecule, and that basically means that this oxygen is not sharing the electrons equally. It's pulling the electrons from the hydrogen as close as it possibly can so that it's giving this section of the water molecule a negative charge and this section of the water molecule a positive charge. So then I asked you guys to go ahead and draw some more in here. All right. And the reason why I asked you to do that is because we have a little story that goes along with water molecules. Because oxygen loves electrons so much, it's kind of like a player, kind of like one of those boys or girls that you might know that likes to chit chat and flirt up every single other boy or girl they talk to. And so oxygen is constantly trying to get a hold of some other hydrogen's electrons. So notice how this one's really close to it. So this oxygen would be like, hey baby, let me get a hold of some of those electrons. And so what would happen is a really strong attraction would form between any oxygen that was near a hydrogen that was possible. So we'll put another oxygen and hydrogen right here. And so they get these really, really strong attractions that hold the water molecules together. And that's why we're using little hearts, all right? Because a very strong attraction. Not great handwriting, but it's a really, really strong attraction, all right? It's just an attraction. This strong attraction is called a hydrogen bond. And this is in your notes that I posted, all right? So a hydrogen bond is a strong attraction. So it's not a real bond, it's just an attraction, kind of like a magnet. A strong attraction that holds water molecules together, but not just water. And other molecules too, if you're wondering what I'm doing. So I'm writing it down for you. So the key is, all right, is hydrogen is a strong attraction that holds water molecules. I always leave something out, right? Holds water molecules together and other molecules too. So it's just a really, 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 really strong attraction, but there's actually no transfer of electrons and no sharing of electrons. It's just an attraction like a magnet. So that's the story of water. So these hydrogen bonds give water really unique properties, really, really cool properties that we will be looking at class today doing little labs. And I will try to set like something up back here so you guys can see that too. So anyways, have a great day. I just wanted to kind of go over this diagram with you and what we discussed in class. And hopefully this video helps. All right, have a great day. Bye.